We speak student!
Verifying trig identities a la Shmoop. Hemlock Jones has been competing for respect as a detective all of his adult life, but he is always outshined by that pesky Sherlock Holmes. If only there was a logic problem I could solve, then I could get the key to the city.
Jones! We've got to solve this riddle to save Candy!
Looks different, 'tis true, but actually the same. Prove their equality, or it's over for your dame. Cosine x plus sine x times tangent x equals secant x.
What do you make of it? Sounds like nonsense to me.
Trigonometry, my dear Wilson. We must show that the sum of cosine x and sine x times tangent x is equal to secant of x. To verify this trig identity, we will substitute other known trig identities until we have equal sides to our equation. We can substitute sine x over cosine x for tangent x. When we multiply sine x by sine x over cosine x, we get that cosine of x plus the fraction sine x over cosine x multiplied by sine x equals secant x. What is it when we take a value times itself?
Squared!
Oh, precisely, my boy. Since we have the product of sines in the second term, we can simplify to cosine of x plus the fraction sine squared of x divided by cosine of x equals secant x. Now what do I do? We know that cosine squared x plus sine squared x equals 1. How could I get to cosine squared x plus sine squared x equals 1 on the left-hand side? Oh, I know. We can multiply the left-hand side by the fraction cosine x over cosine x to get cosine squared of x divided by cosine of x plus the fraction cosine x over cosine x times sine squared x over cosine x equals secant x. Since cosine x over cosine x is just a fancy way to write 1, we're really just multiplying the left side by 1, right? If we simplify the crazy left-hand side, we get cosine squared of x plus sine squared of x over cosine of x equals secant of x. Cosine squared plus sine squared equals 1. So we get 1 divided by cosine x equals secant x. And the definition of secant of x is 1 divided by the cosine of x. So we have solved our riddle. Later that day, Candy is back in Hemlock's arms.
My hero!
Oh, it was nothing, my dear. I'm always looking out for any victim of trig identities.